This one is for you to try. Now, this is an even-numbered problem from the book, so it's not one of the assigned homework problems. It's one where you are going to need to use the quadratic formula, and there weren't that many in the homework, so I didn't want to just put one of those here. Wanted you to have a little bit left to practice on when you're done with the videos. I should just point out, if you try factoring this one, it's just not going to work. Okay, but there are plenty that do factor. You have the option of using the quadratic formula for those if you prefer. I tend to think it's easier to solve by factoring if I'm able to factor. So that's my go-to, and I only use the quadratic formula if it doesn't factor. But I've always had some students who are not crazy about factoring and much prefer the quadratic formula. So as long as it's quadratic, the quadratic formula is a viable option anytime you want to use it. I'm letting you know that you do need to use it here. So pause the video, solve the question, solve the equation. All right, so I already told you this doesn't factor. We can pretty much see why, because we've got just a 1 here and a coefficient of 1 here, so there's no way I'd be able to get that 4 in the middle. Okay. So here, I'm going to just write out that my a, that's the coefficient in front of the squared term, is 1. B is the coefficient in front of the linear term. That's, in this case, cosine to the first power. That's -4. And C is -1. Since this was quadratic in cosine, the quadratic formula isn't going to give me x, it's going to give me cosine of x. And I like to just write out the formula first and then plug in. So it's the opposite of b plus or minus root b squared minus 4ac all over 2a. The opposite of b is the opposite of -4. That's 4. You'll notice I'm in the habit of saying that that's the opposite of b rather than -b. If I say negative, I'm really tempted to write a negative sign, but I'm actually taking the opposite of a negative, so there is no negative sign there. It's a +4. Okay. All right, plus or minus. The square root of b squared will be 16 minus 4 times 1 times -1 all over 2a is just 2. So that's going to be 4 plus or minus the square root of, this becomes 16 plus 4, so that's 20 all over 2. Okay. That's 4 plus or minus, that 20 I can write as 4 times 5. So I can say the square root of 4 is 2, and then root 5 all over 2. I'm going to just distribute that division by 2, so I get 4 over 2 plus or minus 2 root 5 over 2. And then I can simplify, that's 2 plus or minus root 5. Okay. The other thing I could have done to simplify this is just factor out a 2 from on top and then cancel that 2. Either way, I'm going to get to this. Okay, now that's cosine of x. So I've got cosine of x could equal to plus root 5, or cosine of x could equal to minus root 5. That's not possible, because that's going to be bigger than 2. Cosine is never bigger than 1. Not going to happen. But I need to check this one. I need to know whether that's in the appropriate range for cosine or not. If so, I'll keep going. If not, this equation had no solutions. Okay, so let's see, root 5. If I were to square that, I would get 5. Okay, now 2 squared would give me 4. That's a little bit smaller. 3 squared would give me 9. That's a little bit bigger. So since root 5 squared is between 2 squared and 3 squared, root 5 is between 2 and 3. Now, if that was 2, 2 minus 2 would be 0. If that was 3, 2 minus 3 would be -1. Okay. So this is between 0 and -1. So it is in the range of cosine, so I need to keep going, and it's a negative number. Good to know. All right, so where is cosine negative? That would be in quadrant 2 and in quadrant 3. So I'm going to have pictures that look like this, both of which will have the same reference angle. Now what I know about cosine of alpha, the reference angle, is that it's the absolute value of 2 minus root 5. But I should always be able to simplify the absolute value of a number. Remember, we said this was a negative number. When you have the absolute value of a negative number, you get the opposite of that number. So I'm getting the opposite of 2 minus root 5. That's negative 2 plus root 5. And I'd probably just write that as root 5 minus 2. Okay. So alpha is an acute angle whose cosine is that number. Alpha is arc cosine of root 5 minus 2. Okay, so here, this is x is pi minus alpha, so that's going to be pi minus arc cosine of root 5 minus 2. And here, x was pi plus alpha, so that's pi plus arc cosine of root 5 minus 2. Kind of a messy number to write out, but it's the same procedure we use every single time. So my two solutions here between 0 and 2 pi were pi minus arc cosine of root 5 minus 2 and pi plus arc cosine of root 5 minus 2. All solutions, we were working with cosine, so we add a multiple of its period. We add a multiple of 2 pi. So that'll be pi minus arc cosine of root 5 minus 2 plus 2 pi n, and pi plus arc cosine of root 5 minus 2 plus 2 pi n, where n is an integer. Excellent.